Today we're going to look at Chapter 9, Sequences and Series. We're going to look at Section 9.2. We're going to skip 9.1 and take a look at Arithmetic, Sequences, and Series. And there's the objectives. You can take a look at that. We'll explain what all that means. What is a sequence? A sequence is a function whose domain is the set of positive integers. The function values a sub 1, a sub 2, a sub 3, a sub 4, so on to some terminating value k are the terms of the sequence if the domain of the function consists of the first n positive integers only. The sequence is a finite sequence, means it terminates. If it doesn't terminate, it's an infinite sequence. Now, think of a sequence as a pattern that you can recognize. Okay? There's three types of sequences: arithmetic, geometric, and neither. Arithmetic means that you're going to have a common difference between two consecutive terms. For instance, the first one there, 6 minus 2 is 4, 10 minus 6 is 4, 14 minus 10 is 4, and so on. Here we have 7 minus 15 is negative 8, negative 1 minus 7 is negative 8, negative 9 minus 1, negative 1 is negative 8, so it's a constant difference. Geometric, we'll look a little bit more later at these, but geometric consists of a constant ratio between two terms. So 3 divided by 1 is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2, and so on and so forth. Neither would mean that maybe we can find a pattern, but it's not a ratio or a difference. So 0, 2, 0, 2, 0, 2, 0, we can see the pattern, but we don't know what there is not a constant ratio or difference. Now, here, this one, negative 5, negative 4, 9, 40, 95, I'm not sure if there even is a pattern, but it certainly is not arithmetic or geometric. So some notation that we have to get used to. I'm going to call this a sub n. That means the nth term in my sequence. So a sub 1 would be the first term. A sub 10 would be the 10th term. Okay? So it has a term value a and a position number n. So for an arithmetic sequence, okay, I'm going to have something like this. A sub n is the first term, a sub 1, plus n minus 1 differences. Okay? Geometric, a sub n equals a sub 1 times a n minus 1 ratios. Okay? So, and neither would, now an example that would be a sub n equals n squared plus 1. That's neither arithmetic nor geometric. So, series notation, we'll look at this. I've got this uppercase epsilon. It's not just used for Greek sorority houses. Epsilon means a summation. I'm going to sum this term 2i, starting at I equals 1 and finishing at I equals 4. So this is the lower limit, this is the upper limit, and this is the index. So if I had this sum of I equals 1 to 4 of 2i, well, if I is 1, it's going to be 2. I is 2 is 2 times 2 is 4. 2 times 3 is 6, and my upper limit 4. 2 times 4 is 8. So this would be equal to 20. Now, a sequence is arithmetic if the difference between consecutive terms is the same. So a sub 1 plus my difference is going to give me my next term, a sub 2. A sub 5 is going to get plus my difference is going to give me a sub 6. So any term in the sequence, a sub n, is going to be the previous term plus the difference. Now, that's called the common difference. The nth term of the arithmetic sequence has the form like this, or y equals dx plus c, where d is the slope of the line. So an arithmetic sequence is going to have a nice linear look to it. Okay? The form that we are going to be using are these ones here. A sub n is equal to a sub 1 plus n minus 1d, or more general form of it, if I know two of the terms in an arithmetic sequence, I know the nth term and I know the kth term, well, I can write it like this to find any nth term. So let's take a look at some easy ones here. If I have this sequence, a sub n is 5 plus 3n, well, if n is 1, that's going to be 3. 3 plus 5 is equal to 8. And 5 plus 6 is equal to 11, and you're going to see that it's going to go up by 3s, 14, 17, 20. So yes, it is arithmetic, and my common difference is 3. So let's get used to this formula over here. So I'm going to assume that this one, n begins with 1 is my lowest one here. So a sub 1 is equal to 0. So my first term is 0. My difference is negative 2/3. So 0, negative 2/3, negative 4/3, all the way down the line. So I can write that using this formula here as a sub n is equal to a sub k plus that n minus k times my difference, which is, we figured out, was negative 2/3. Let's take a look at this one. 10, 5, 0, negative 5, negative 10. My difference is negative 5. So I could write it this way. Now this one's a little trickier. I've got a sub 5 is equal to as 94. A sub 7 is equal to 76. And I could write this as a sub 7. I'm going to substitute 7 for n, and I'm going to substitute 5 for k. So a sub 7 is equal to a sub 5 plus 7 minus 5 times my difference, which I don't know yet. That's what I'm solving for. So if I do this, a sub 7 is 76, a sub 5 is 94. So 2d is equal to, if I rewrite this, 76 minus 94, and I could solve that d is equal to negative 9. So now that I know what my difference is, I can plug it in back into this equation here. All right, so a couple more that aren't too hard. Let's plug in the first 5 terms. So if a is equal to 5 and my difference is 6, so it's going to be 5, 11, 17, 23, 29, not too hard. Here I've got 16.5 and I want to, my difference is 0.25, so 16.5 is my first term, 16.75, 17, 17.25, 17.5, not too hard. All right, let's find the 9th term here. If I know what a sub 1 is and a sub 2, well, then I know that my difference is 10. So my 9th term, I could use this formula knowing that a sub 9 is going to be equal to a sub k, and I'll use 1 because I know what that is, plus n minus k, so 9 minus 1, times my difference d, which is 10. And I can figure out that a sub 9 is equal to a sub 1, which is 3, plus n minus k, which is 8, times my difference 10, and I can figure out that's equal to 83. Now, we can use our calculators to do a lot of this, but it takes a little bit of work to understand how to do it and make sure that you got all the right things. The first thing that we want to do, if I want to find and plot this sequence, the first thing I need to do is go into my mode settings and set the mode to sequence. Okay, there's some other things here. We're normally on function. We want to move it and enter sequence. And if we're just doing separate points, we'll use dot. Now on the newer calculators, it's going to say thick dot or thin dot. I usually use thick dot there, but you want to set it to seq and you want to set it to dot, okay, or sequence and thick dot. Then go to the window. It's going to look a little bit different than when we did function. So now it's going to ask you for your minimum n, which is going to be 1. And we'll say maximum n is 10, and then my plot starts at 1 and it steps 1, and so on. Then we can go to the y equals screen and enter my equation, negative 5 plus 2n. And my value for my n min, so 1, so 2 plus negative 5 would be negative 3. I think on the newer calculators, you don't have those brackets there. Now, if I wanted to, I could graph that, hit the graph button, or I could use a table to display my values. And I could use, I want to go to table set, which is above the window function, and set it to ask, and then go to the table function, and I can plug in, oh, let's find the 34th term, and it'll tell me, oh, your value would be 63. So a sub n would be, or a sub 34 would be equal to 63. So I would suggest practicing that on your calculator because that will come in very handy for a lot of these problems. All right, we'll take a look at the first 8 on the in-class practice here. Let me switch over to that real quickly. So here I've got what's a common difference. I could do this in my head probably, but I just wanted to show you. 5 halves minus 3 is negative 1 half. 2 minus 5 halves is negative 1 half. And the other ones, excuse me, common difference is negative 1 half. So yes, indeed it is a arithmetic series. Here, again, I could do this in my head, but just showing you 5.7 minus 5.3 is 0.4. 6.1 minus 5.7 is 0.4, and for the other ones, it's 0.4 as well. So yes, it is an arithmetic sequence. Now this one says find the first 5 terms, determine if the sequence is arithmetic. Okay, I could probably do this one in my head, but I'll write it out for you here. So a sub 1, I'm going to substitute n is equal to 1. So 1 plus 1 minus 1 times 4, well, that's just equal to 1. Plug in n equals 2, so it's going to equal 1 plus 4 is 5. And then plug in n equals 3, 1 plus 8 is 9, then 13, 17. Yes, this is an arithmetic sequence. It goes up by 4 every time. This one, if I plugged in for n equals 1, got 2 to the 1 minus 1 power would be 1. Plug in 2 for n, 2 to the 2 minus 1, it means 2, and then it goes 4, 8, 16. No, that's not an arithmetic sequence because it goes up by powers. It does not go up by a constant difference. For number 5, find the formula for a sub n. I'm going to use this formula here. I know what a sub 1 is, and I know what my difference is, so I'm going to plug in d for my difference. I'm going to plug in 1 for k, so a sub n is equal to a sub 1, which we said is 1, plus n minus 1 times 3. We could have left it like this, but, well, we could combine like terms and say a n is equal to 3n minus 2. For number 6 here, we had an example like this in the slides, but d is equal to negative 5. Again, use that same formula, and my plug in 1 for k, so a sub 1 is 10, and then n minus 1 times negative 5 is my difference, and I could rewrite that as a sub n is equal to negative 5n plus 15. 7 and 8 here says write the first 5 terms. We had an example like this in the slides. Again, 16.5, 16.75, and so on. This one's a little trickier. I've got, again, I want to use this formula. And a sub 10, that's going to be my n. A sub 4 is going to be my k. So a sub 10 is equal to a sub 4, n minus k, so 10 minus 4 times my difference d. I don't know what my difference is yet. I got to figure it out. So a sub 10 is 46, a sub 4 is 16, plus 6d. Do a little bit of math here, figure out that d is equal to 5. So now I can plug in my equation here. A sub 1 is equal to a sub 4 plus 1 minus 4. Now I'm substituting 1 for n. And that tells me that a sub 1 is equal to 16 plus minus 15 is equal to 1. Now I kind of, there it is. So now my first 5 terms then, if my difference is 5, and my first term is 1, 1, 5, 6, 11, 16, 21. So let me give you a second to get those notes down. All right, and then we'll continue on. So these values we already got. All right, so let's look at a definition of partial sums. Again, a partial sum, we're going to go from 1 to n of this series, this sequence. So we're going to add up the first n terms, and we can do this on our calculator using what's called sum function. So I is your index, 1 is your lower limit, n is your upper limit, and we can plug that in whatever n we want. So sums of an arithmetic sequence, okay, find the sum of the first 100 positive integers. This mathematician did it back in 1784 when he was only 7 years old without a calculator in only a few minutes. How did he do it? Well, he took each series and he went from 1 to a sub n. And he also did it again, but this time going from top to bottom, from a sub n down to a sub 1. If you add the two series together, you've got the two series is a sub 1 plus a sub n. Here the d's cancel out, so I have a sub 1 plus a sub n. And here the two d's cancel out, a sub 1 plus a sub n. You get all the way to the n, and you get a sub 1 plus a sub n again. So that is n times a sub 1 plus a sub n. You're going to have n of those, and you're going to divide it by 2. Okay? So the sum of two arithmetic sequences added together. And so we can figure out that for 100, this first 100, it's going to be 100 times 1, which is my first n, plus 100, which was my a sub n, and divide that all by 2, 50, 50. So that's a pretty easy way to do that. Okay. Here are some properties of sums. Okay, I'm not going to make you memorize those, but you might want to keep this slide handy if you need it. And here was an example of 12 days of Christmas. How many different gifts did the guy give to his true love? We're not going to go through that right now. But if we figured it all out, it turns out to be 364 gifts. There they all are. All right. Now, we can do a lot of this on our calculator. If I want to do this on my calculator, I'm going to go to the math functions and pick the sum function. And my screen is going to show something like this, where it's got the sum and it's got an index, it's got a lower bound and an upper bound that it wants you to fill in, and then it's got parentheses. It's very important to make sure that you put everything inside the set of parentheses that it gives you. Because if it's outside of that set of parentheses, it's only going to sum what's inside. So that's a very important thing. That's a very, very common mistake that students make. So just put everything inside that set of parentheses that it gives you. Okay, so if I want to sum this up and plug this in, I can sum n equals 0 to 4 of 3n minus 2. If I plug it in my calculator, it equals 20. So you might want to practice on your calculator, make sure you can figure that out. Okay, so if I wanted to check my answers by hand, I could write it all out. So if I is 0, 3 times 0 minus 2 is equal to -2, and then so on and so forth. And it indeed equals 20. But that's definitely the hard and long way to do it. You can understand how to do it on your calculator, save yourself tons of time. All right, well, let's look at this sum. We can use calculator to figure this out, but we got to do a little work first. If I have 4, 10, 16, 22, well, I can see my difference is 6. I could have figured out that 10 minus 4 is equal to 6. But then plugging into my equation, a sub n, I will use k is equal to 1. So that's going to be a sub 1 is 4 minus n minus k, or n minus 1 times d, which is 6. And I want to find the nth term. I want to find the nth term, which is going to be equal to 52, and that turns out to be a sub 9 is equal to 4 plus 8 times 6 is equal to 52. So now I know that my lower index is 1, my upper index is 9, and I just took this equation and kind of rewrote it here. And if I plug that into my calculator, it gives me 252. I could have written the equation like this. It doesn't matter either way. All right, let's take a look at the last of the class in-class practice here. So here it says the first 10 terms of the sequence. I only did the first 5, but practice on your calculator, plugging in the different values, and see if you can come up with this. Okay? Or you could even do it by hand. If n is equal to 1, then 8 minus 0.3 would be 7.7, and so on and so forth. But practice with your calculator. Make sure you know how to do that. Okay, this one. I want to find the first n terms. If this is my first 4 terms, I want to find the sum of these. My difference I can tell just by looking at it is negative 0.5. My a sub 1 is 4.2, so I'll substitute k is equal to 1. So a sub 1 is 4.2, n minus 1, because k is 1, times my difference, which is negative 0.5. Plug that into my calculator from 1 to, again, my upper limit's 12. If I plug that into my calculator, I should come up with 17.4. For number 11 here, I can see that my difference is negative 3. If my a sub 1 is 40, and let's use k is equal to 1, so a sub k is a sub 1, which is 40, n minus k, which is 1, times my difference, which is negative 3. So I'm going to use my calculator to go from 1 to my upper limit of 10. So n equals 1 to 10. I'm going to sum all this up, and I should come up with 265. So again, practice on your calculator. This is one that I could have done without a calculator by doing n sub my n equals 10 to 100. 10 plus 100 is 110 times 6 would be 60,060 divided by 2, but let's just do it with our calculator, and it turns out to be 30,030. Again, could do this in the hard way, or just simply use our calculators, make sure we do it correctly, 355. So practice those to make sure you can understand how to get those answers. Finally, number 14, plug it into your calculator and see if you can do it from n equals 0 to 100 of this equation, and should come up with a nice value like that. All right, so hopefully, I know there's a lot of calculations and a lot of things to comprehend here, but hopefully you can start to understand these, and let me know if you are having any problems, but that's where we're going to stop for today. So do the web assign. There will not be quizzes or tests coming up. So take a look at the book if you need to. Take a look at the watch it's on okay. And if you need to, go back and look at the video. So all right, that's as far as we're going to get today. And we will stop.